Hi, today we're going to talk about C language functions as part of our intro to Objective-C. Now, Objective-C methods are called using a different syntax than straight C language functions, but a lot of Objective-C uses C language functions, and so when we look at the iPhone and iPad API, we're going to see a lot of C language functions being thrown around. And so understanding this is one of the keys to understanding Objective-C and how to program with the iPhone. So we're going to be looking at declaring a function, and we use header files for that purpose, defining a function, the parameters of a function, returning a value and the meaning of the void keyword, and then passing by value versus passing by reference with our parameters, and then we'll have a short demo. So first of all, what is a function? A function is any repeated portion of code. A function can accept 0 or more parameters in a parameter list that's delimited by parentheses, and it may return a single value. Repeated code, when you're programming, any code that you end up repeating in your program, should be refactored or extracted into functions. It makes your meaning clearer for someone else or yourself later looking at your code, and it also is a better practice as far as programming is concerned in general. Functions should always be declared before they're defined or called. The reason for this is in C, if you call a function before you have defined it in your source code, that won't work. You need to either define the function in the source code file before you make a call to it, or put a function header above where you call it, and then define your functions lower in the file. To declare a function, and this is normally done in a header file, we could do it in a C file, but normally it's done in the header file. First of all, we declare the return type, and here the return type is an integer, and then the name of the function, in this case, is add, and add expects two parameters, and they are an integer and an integer. And these are what I'm naming the parameters as far as the function is concerned. So I have an integer called num1 and an integer called num2 that I'm passing into the function, and I'm going to do something with those, probably add them, and return the result as an integer. Note the semicolon out here. The semicolon here is used to say that this header, this function header, is merely a declaration. Later, I will define it, and that definition must be in our C file or in another C file that's included when we include this header. Here's a function definition syntax. It's the same as the declaration. Notice that I'm returning an integer, and I have add, and then my parameter list as before, no semicolon here, and then my function definition is actually between curly braces. And notice that after the terminating curly brace, there's no semicolon there either. Here, I'm telling it to return the sum of num1 and num2. And so this add function is very simple. What this does is it adds num1 and num2 and returns those, and because these are both integers, when I add them, I'm going to get an integer, and I'm returning into here. The return type of a function can be any scalar value, or it can be a pointer to something else. It could be a pointer to a C struct. In Objective-C, it can be a pointer to an object, and so forth. If a function, though, returns no value at all, we specify a return type of void. So if, for example, the add function didn't return a value, if we were doing it some other way that we're going to talk about here in a moment, then we would specify void instead of int before that add. Parameters to a function can be passed in one of two ways. We can either pass by value, which means that the actual value enclosed in a variable is passed to the function. In other words, if I have a variable called a, and I say a equals 7 as a statement, then I am passing 7 into the function. The function cannot modify a parameter that's passed by value. It can do some adding, it can do some math, it could do something with that value and then return something else, but it cannot actually modify a parameter passed by value. However, if we want to modify the parameters that are passed into a function, we need to pass them by reference. In passing by reference, we actually don't pass a contents of a variable, we pass a pointer, we pass the address of a variable, and that is what we pass to the function. And the function can modify a parameter that's passed by reference. An example of this is scanf. Scanf does have a return type. I believe it returns the count of what was scanned in. But what it actually does, we tell it to scan in. If we tell scanf to scan in integers, then we are passing the addresses of the integer variables that we want scanf to scan into. So that's how that works. So let's talk a little bit about these pointers. And there's a couple of operators. The first one's called the indirection operator. The indirection operator is used in a couple of different ways. And the indirection operator is a star operator. This is not multiplication. Used in this way, it's always a unary operator. It only has one argument. To declare a pointer variable is one way that we use the indirection operator. So here I have an integer a that I'm setting equal to 5. And here I have an integer pointer, and here's my indirection operator, called PA. And in C language, it's very common to proceed or to have a variable name called P something, which means that it's a pointer. It's also used, the indirection operator, to obtain or set the contents of a pointer. And here, I'm just saying that if I had set the contents of PA, I'm setting the integer value B to whatever PA is pointing to, the contents of the address of PA. And then the address operator, or the address of operator, which is an ampersand, is used to obtain the address of a variable. So here, I'm setting that pointer PA equal to the address of A. So A contains 5, but A also has an address in memory. And that memory address is what goes into PA. And typically, we don't inspect the actual numeric address of a pointer. We use them in other ways. But in this case, since now I have the address of A in PA, I can assign B to the contents of PA. So when I do this, after I've done this, B has a value of 5. So now we're going to have a demo in which we declare and define a couple of functions. We'll have a header file. And then I'll show you how to call the functions that we've declared, and also how to pass parameters by value and how to pass them by reference. So let's look at this demo now. We'll close this view. So here we have our C language main function. I've included standardIO.h, and standardIO.h is included here because I'm calling the printf function. And then I also include something called myfunctions.h, and this is going to have the header definitions for add and swap. Here's where add and swap are defined. We can see here that I've set up 3 integer values, and num1 or n1 equal to 4, n2 equal to 7, and then I've also set up a third value, integer value called result, that I'm going to use for some math. So let's look at myfunctions.h. Here's this file. First of all, I have a couple of C language preprocessor directives. This one says, if not defined, if ndef, if not defined, functions underscore myfunctions underscore h, and this really is saying that there is a myfunctions.h file inside the functions program, which is what this is, We can see that. If that's not defined, define it. And define it as this. And here's my end if. So if the function is not already defined, go ahead and define it. And here we have our two declarations, add, which is num1 and num2 as parameters, both integers, and returns an integer, and here's the semicolon, and then swap, which is a pointer to an integer and a pointer to an integer, and don't return anything. So here's our void type, the void return. So now let's look at the definitions of these. Here's add. Notice there's no semicolon here. And add is passing its parameters by value. It passes an integer, num1, and an integer, num2, adds them, and returns it. And because these are both integers, the return type is int. So that's very simple. And here's swap. It's a little bit different looking. Swap takes a pointer to an integer and a pointer to an integer, and swap sets up a variable called temp, which is an integer variable. And here I'm using that indirection operator in the other way, and I'm using it as what I would call the contents of operator. So we assign temp the contents of the address pointed to by this variable. And then I set num1 equal to num2. The contents of num1 becomes the contents of num2, and now num1 and num2 are the same value. And then I set num2 equal to that temporary integer. And this again is the contents of num2 equal to temp. And that effectively swaps them. I'm not returning anything. I merely fall out of the bottom of this function. And when I have done that, whatever I pass in will have been swapped. So let's look at this. N1 is 4, N2 is 7. Here's my result. And I say result equals add. Here's my function add N1 and N2. Notice that the parameter names when I pass into the function do not have to be the same as the parameter names in the definition or the declaration of the function. So N1 and N2 get added, and that's put into result, and then I have a printf statement that merely prints the sum of whatever integer, and whatever integer is whatever integer, and those three integers are replaced by N1, N2, and result. So this is pretty printing of the sum of 4 and 7 is 11. And here I print out before swapping, N1 is an integer and N2 is an integer, and I replace this integer with N1 and this integer with N2. And then I go ahead and swap. Now notice that I'm using the address operator here. I could have set up two pointers. I could have said pn1 equal to address of n1 and pn2 equal to address of n2, that address of operator, this operator here. But I can do the same thing just by taking the address of n1 and the address of n2 using our address of operator. And then I print, after swapping, n1 is an integer and n2 is an integer, and I still use n1 and n2 in that order. This will tell us if these two actually, their contents got swapped. So let's run this. In order to run and observe the output of a straight C language program in Xcode, we need to open up the output window, and that's done by this second button here. And this is the output and debug window. So when we run the code, a successful build, and we see this printf statement has printed the sum of 4 and 7 is 11, just as we expected. This printf statement, before swapping, n1 is 4 and n2 is 7, and then we swap, and then this printf statement, after swapping, n1 is 7 and n2 is 4. So you might be asking, why would we define functions that use pass by reference in their parameters rather than pass by value? And the answer, put simply, is we can only return one value from a function whose parameters are passed by reference. We can't return a list of values. We could return a pointer to an array, and that would effectively do the same thing. But for simplicity's sake, we can only return one thing, one entity from a function whose parameters are passed by value. However, we can modify anything in this list that is passed by reference. And so that's why, because effectively, if we want to return, quote, return multiple values from a function, we need to pass by reference. And so many times we won't actually have a return declared. It'll be declared as void. But we'll pass in a list of parameters as passed by reference and then modify their values inside the function. So this is a very slick way to get things done in C. And the reason we can do this is because of the power that we have, because C exposes these pointers. These are also exposed in ObjectiveC because ObjectiveC is built on top of C. So these are some things to think about as we continue our study of ObjectiveC, because we are going to see C language, straight C language functions. We are going to see parameters being passed by reference rather than value. We are going to see pointers to values many times in ObjectiveC and in the iPhone and iPad APIs. So this is sort of preparatory work and a discussion of really C language functions as opposed to ObjectiveC methods, but we will be seeing these things as we progress through the course. Thank you very much.